In this video, I would like to introduce the paddy farming knowledge management. First and foremost, I would like to discuss the current technology that are used to support sustainability and productivities of paddy farming. The first technology I would like to introduce is the weather forecasting and disaster management, which is an AI-based model that analyzes historical and real-time weather data to predict rainfalls and extreme weather events. This technology helps farmers to align farming planning with optimal weather conditions and prepare for monsoons to reduce significant crop loss from floods or extreme weather. The second technology is AI-powered smart fertilizer drones, which autonomously navigates with a pre-programmed GPS path, detects nutrient deficiency using AI and computer visions, and adjusts the amounts of fertilizers applied based on the crop conditions. It helps reduce over-fertilizations and environmental damage, as well as improve nutrient efficiency to increase crop yields. The last technology is pest and disease detections. It uses AI to analyze crops image to detect signs of pest or disease and recommends the target treatments or prevention strategies. The technology enables early interventions and reduce chemical pesticide use. Next, I would like to talk about the expert system contributions to decision making. The first contribution is provides insights and recommendations. For instance, the expert system analyzes weather forecasts and crops health image to recommend the best planting dates or specific fertilizers for the current crop conditions. Additionally, the expert system contributes to decision making by reducing human errors and biases. For example, it helps farmers to avoid misdiagnosis disease to prevent incorrect chemical use. Lastly, it also contributed by improving the speed of problem solving, where it quickly suggests targeted pesticides or biological controls during a pest outbreak, allowing faster containment and minimal loss. Moving on to the next sections, I'm going to explain the life cycles, expert development life cycles, ESDLC. The first phase of the ESDLC is problem identification, where we need to know what the challenges are in the paddy farming. The next phase is the feasibility studies, where we need to understand the technical, operational, and economic feasibility. The third phase will be the project planning, which is the phase of defining the project scope, timeline, budget, and stakeholders. Moving on to the knowledge acquisition phase, which is the phase to capture and extract the domain knowledge through interviews with the agriculture experts, observe the farmers' daily work, and review the research. The fifth phase is knowledge representation phase. In this phase, the collected knowledge is codified using if-then rules or ontologies. The next phase is knowledge implementation, which is the phase where the developer builds a working prototype using the formalized knowledge. Phase 7 is verifications and validations. In this phase, the prototype is verified and validated to ensure that developed systems is accurate. Revising it is necessary according to the agricultural experts' feedback. Next is installations, transitions, and validations. In this phase, we need to deploy the final prototype, provides training to the farmers, and develops a documentation and user manual. The last phase is the life cycles, is operations, evaluations, and maintenance, which the phase starts running the system, gather user feedbacks, and regularly update the knowledge base to reflect new farming techniques or disease outbreaks. So, after explaining all the phases in ESDLC, in my opinion, I consider knowledge acquisitions will be the most critical phase in ESDLC. This is because if the system is built on incomplete, outdated, or inaccurate knowledge, the recommendations made by the system will be unreliable, misguiding the farmers to make bad decisions. Consequently, it might lead to significant crop loss. That's all for the videos. Thank you.